This lecture is on density. Now, density is a ratio. And it's a ratio of two things that we can measure. It's the ratio of the mass of something and its volume. So how much space it takes up. So the way that we're going to write this equation is density equals mass divided by volume. Now, you need to be able to rearrange this equation right here so you can solve for any of the variables. So if I give you mass and volume, you could solve for the density. That's an easy one because that's in the equation. But if I give you the mass and the density, then you should be able to solve for the volume. So really this just goes back to things you learned in Algebra 1 where you are rearranging an equation to solve for a variable. Now the next thing is units. So your units are going to come from the problem. So you're always going to have a mass unit over a volume unit. So you might have grams over liters. Grams is your mass unit, liters is your volume. You could have something like kilograms per milliliter. This is your mass unit, this is your volume. You also might see something like milligrams per centimeter cubed, okay? So this is another volume unit that we usually think of, oh, it's centimeters, it's distance, but we're going to talk in just a second about why that is a volume unit. Also, make sure that you have a calculator when you are doing these problems. You're going to want to use one for the rest of this lecture, so if you do not have one right now, go ahead and pause it and get one before you continue. Right, so density is what we call an intensive property. So what this means is that the density is going to stay the same no matter what size the sample is. What does that mean? So the density of water is going to stay the same whether I have it in a cup or whether I have a sample in a swimming pool. No matter how much of it I take, the density is not going to change. So it's not dependent on the amount or the size of your sample. All right, so there may be times where you are asked to find the volume and it's not explicitly given to you in the problem. Like it may not say that the volume of this object is 12 centimeters cubed. You have to find that. So a few ways we can do that. First one, if we are looking at something that is a cube or a square shape, so has sides and it's a solid, we're going to use length times width times height. Okay, you've probably done that in maybe geometry, and what you have to remember is that each of these, the length has a unit, the width has a unit, and the height has the unit. The key on this is to make sure all of the units are the same for your length, your width, and your height. Because what we end up with is, let's say that all of these were written in meters. We have meters times meters, which is where we get meters cubed. So that's where that centimeters cubed comes from. It's because although we normally think about that we're just multiplying the numbers here, you have to remember that you're also multiplying the units. The next thing is if we're measuring the volume of a liquid. What we're going to use for that is a graduated cylinder. Some of you may have used these before. I'm sure all of you have seen them. And units on this, you're going to see milliliters and liters for the most part on this. So you just read it, and then you read, there's these little lines here. And then you're just going to read it to wherever that meniscus is. So that's that lowest point. Okay? So then you'd read it at wherever that was. Okay, and we're going to do some stuff in lab to give you practice with reading things in a graduated cylinder. But just remember, you also have units on that as well. The third thing is displacement. Now, it's ideal if we have something that's a cube, we can just measure it with a ruler or a meter stick. Or if it's a liquid, we can just throw it in a graduated cylinder. But doesn't always happen, okay? A lot of the times we want to measure the volume of something that is irregular shaped. It's not something that can just drop in a graduated cylinder or something that we can use that ruler or that meter shape for. So what we're going to use is displacement. So what displacement is we're going to use water in a graduated cylinder to see how much space an object takes up. So for example, think about if I'm sure most of you have taken a bath at some point. So before you get in the bathtub, think about the level of that water. And then you get in the bathtub, and what happens? That water rises. Why does that water rise? Well, it's because you are taking up space that the water cannot, so it goes up. Because the water, you are displacing or replacing the space where that water once was. So the water has to go somewhere, so it rises in your bathtub. This is the exact same thing. Okay? So to find the volume of an object, the first thing that you're going to do is you're going to measure water in your graduated cylinder. I'm abbreviating this. You can write it out if you need to. Grad cylinder. Now, make sure that you have units. You guys are going to hear me saying this for the rest of the year. Units, 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 units. Did you measure how many it was in milliliters, or did you measure how much it was in liters? The next thing that you're going to do, erase these here. Number 2 is you are going to drop your object into your cylinder that already has the water in it, the one that you measured up here in number 1. And then the third thing is you're going to find the difference in volume. So let's say we started at 50 mLs, and then we dropped our irregular shaped object, and we measured the water to be 70 mLs. So our difference between these is 20 ml. So that is our volume of this object. Now remember, you always want to take your ending and subtract your starting, okay? Don't add them together. What I see a lot is I see this value right here, the 70, get used as the volume. No, you need to remember that most of that volume comes from the water that's in the cylinder. All we want is the volume of the object. So make sure that you're thinking about this and being aware that this is the value that we're looking for. All right, so a few practice problems here. Skip that. That was for the last one. All right, so practice problems. Let's say you're given in a problem that the mass of the object is 25 grams and the volume is 5 liters. What is the density. First thing I always do is write out the equation. Density equals mass over volume. Then plug those values into that equation. So my mass is 25 grams, units, units, units. Volume is 5 liters, and that equals my density. So this is an easy one. All I have to do is solve here. So 25 divided by 5 gives me 5. My units on this are grams over liters. Okay? Easy enough. Didn't really need our calculator for that one, but you will be getting numbers that you need a calculator for. But the key on this is really, it's going to make your life so much easier if you keep those units throughout the whole problem. And you're going to see why in just a few practice problems. Alright, so our next one, our density is 7.86 grams per centimeter cubed. Our mass is 214.6 grams. What is our volume? First thing I do, write out my equation. Now, my suggestion, there are a lot of people that try and memorize the different equations for the different variables. Just memorize this and then rearrange it. It's much easier and you're not going to get yourself confused. Okay, so just learn one equation and then rearrange it from there. So my suggestion and recommendation for you is plug in always into this equation here. So I'm going to plug this in. Okay, make sure that you have this data over here because I'm going to erase it. The 7.86 and the 214. We need more space here. So we know that we're solving for our volume. Alright, so it gives us that our density equals 7.86 grams per centimeter cubed, and that equals 214.6 grams divided by our volume. Now, we want to get the volume unit by itself. So, in order to do that, we're going to need to do a little bit of rearranging. So, I'm going to bring the volume to this side. So, now I have 7.86 grams per centimeter cubed times my volume equals 214.6 grams. Still looking for this one, so now I'm going to pull this here. Since I'm multiplying on this side, I'm going to divide on this side. So V equals 214.6 grams over 7.86 grams per centimeter cubed. So now, here's the cool thing. I have grams on the top, I have grams on the bottom, and they cancel, so now I'm left with 1 unit. And this unit is a unit for volume. What am I solving for? Volume. This is why you want to make sure that you're keeping track of your units, because it helps you make sure that you are actually doing the right equation. So now you just plug in 214.6 divided by 7.86 in your calculator, and you should be getting something like 27.3 centimeters cubed. Alright, so we'll do one more problem here. So you're given that your density equals 12.6 grams per liter. Volume equals 242 milliliters, and we're looking for the mass. So remember, density equals mass over volume. So let's go ahead and plug these into our equation. 12.6 grams per liter equals mass over 242 milliliters. So we're trying to isolate the m on one side of our equation. So in order to do that, I'm going to move my volume over here. I'm dividing on this side, so I'm going to multiply on the other. 12.6 grams, I'm going to write it like this so you can see it, per liter, and we're going to multiply that by 242 milliliters, and that's going to equal our mass. So remember what we did before. We made sure that our units canceled. But look at our units here. We have milliliters and we have liters. These are not the same. Yes, they are both volume units, but they are not the same. Therefore, they do not cancel. So what do we have to do? We're going to have to use that metric conversion that you've already done. You're going to have to do that to make these units the same. Now, when you are converting units, convert the one that is a single unit. So see how this is just milliliters? Do not convert the one that has 2 units, the one with grams and liters. Okay? Because when you're converting, you're messing with this grams unit as well. So we're only trying to deal with 1 unit at a time. So what we want to do is we want to make this 242 milliliters into liters, so they will cancel. So if you remember back to your metric conversion, find that decimal point, and from milliliters to liters, you're going to move 3 spots, 1, 2, 3, to the left. So you're left with 0.242 liters. So what are we going to do? We're going to plug that back in here. So it's the same value, it's just written with a different unit. 0.242 liters. So now my liters cancel. I'm going to be left with grams, which is a mass unit, okay? So now we're just going to multiply across. 12.6 times 0.242 should be getting something like 3.05. Unit I'm left with is grams, okay? So make sure, I'm going to say it again, you've heard it 1,000 times already in this video, you're going to hear it 1,000 times more this week. Units, units, units. Never have a number that is written without a unit, okay? Make sure that you have these in there. All right, so there's a few practice problems for you to do. As always, if you have any questions, please let me know. Good luck.